Is it? Okay, that's good. So I guess I'll get started now because it's already 10 a.m. So thank you very much for showing up for my talk. I'll be talking about Hudson, which is the continuous integration engine I implemented in Java. So the idea of continuous integration, just to recap, is for having a program that looks for changes in a project constantly, and whenever it detects one, it starts to build a project and it produces the result, like the distribution zip file or the table and that sort of things. And then it publishes the result for other people to consume. And by doing so, it keeps track of how your project is used in other places. This is often useful when you have a graph of projects that are dependent on each other. And then because it's a server, which sort of exposes all those information to people, it brings the transparency to the projects. It's an open source project hosted on java.net, where many Java-based open source projects are available. So this is a URL, and the code is implemented in Java, as the hosting site suggests. And one of the key points of Hudson is its extensible architecture, and so that enables the community to develop a lot of plugins to extend the capability of Hudson to various different areas. And that's been one of the big factors in success of Hudson. The project has been very active. According to Olo, the statistics site for open source project, it's supposed to have like 116 year worth of the code. And then the project itself is 3 years old if I look back to CVS commit history. And I've been pulling the 185 releases to date, and I'll talk more about this later. And I currently have maybe a bit more than 2,000 committers working on various different areas. Many work on plugins of their own, which are hosted in the same repository. Some work on the core code. So it's a very active project all in all. So again, to come back to what Hudson does, it's really sort of, the idea of it is pretty simple, that you tell Hudson to listen to your source code management system changes by some means. One way to do that is to hook up to the notification emails, because in that way you could avoid the cost of polling, which would be expensive. But you could also tell it to do the polling if that's the only way to configure. And by getting the notification from SCM, it can trigger a build. And then depending on how long your build takes, it basically takes the same amount of time. But at the end of the day, you can capture the log of the build, the resulting files, the test reports, the code coverage report, and that sort of things. And you can make it all available on the Hudson site. And by using those artifacts, you could have other programs or other people downloading those artifacts, or maybe browse the Java doc, or see the generated documentation and so on, which is often handy when you're talking with someone else on the phone about some part of the system. Then you need to it's much convenient to be able to see the same thing and then discuss about that. So the other, obviously, more useful feature is look at the test results or test failures when that happens. And then once you do those things, you can then trigger notifications. So often when test failure happens, it's useful to tell some human beings that there are regressions. So you can do that by using some means like instant messaging or the emails. So the reason why something like this is useful is because what I observed in my team during my day job, and I suspect that many of those issues applies to you as well. So let's say you have a team of developers, and one person makes a change in the code base in a Monday morning, and that actually contains some regression, which happens occasionally. And then what happens is, because often without the continuous integration, you set up some kind of nightly builds, and then the other teams, like the testing team, work off against these nightly builds. So in this setup, the earliest moment when the testing team, the SQE team, can find an issue is to pick up the nightly build of the Monday night. And that means the earliest moment the developer recognizes about this regression is going to be Tuesday morning. So we already wasted 24 hours since the regression came into the code base until it was discovered. And then if it takes more cycles to fix it, for example, maybe the first attempt to fix this might fail, actually. And then you're adding one more day to this round trip time. So all in all, it adds up to a lot of time before the problem gets recognized to the problem gets fixed, and that's not good. By having something like Hudson, which is constantly sort of building and testing and making the results available, almost as soon as someone makes a change, you can see that change causing a regression. And in that way, you could fix that in a matter of hours, not matter of days. And that improves the quality of your software. Or another thing is this notification of the test result. The classic way of set up this kind of continuous test execution is to have some kind of cron job that essentially just send out the test result, regardless of there was a failure or the no failure. So what that happened is maybe the first week the people are enthusiastic that now the final tests are running automatically, and maybe they look at the test reports more carefully. But the problem is when you bombard people with all those emails, they start to lose attention. And then people won't stop looking at those emails. So quickly, no one look at those emails anymore. So when the regression happens, no one gets noticed. And then it won't get discovered until it's too late. So having a server that sort of keeps track of all the history, not just a one-time execution like cron, it can do more sophisticated analysis about the test reports. So it could actually tell that there are 5 failures, but the 3 of them are new, 2 has been failing for a long time. And then so it could do things like calling attention to those 3 new bugs, because those are new regressions that need more attention. So that's the kind of thing that Hudson does to improve your life. So the main theme of this, or the main idea behind something like Hudson, I hope by now is somewhat obvious. The first important part is to bring automation. There are lots of things that we developers do which can be automated. And if we manage to let computers do those works, then we, the people, could get to work on more interesting things. We need to write a lot of software, and we just don't have enough time to waste on these mundane things. So Hudson helps you automate various things. The other thing is to reduce the turnaround time. I showed the early example where it takes days to get a fix to the regressions, and that's not good. And part of the reason that's not good is because it forces people to do context switching. If you can work on the same thing in short amount of time and get it done with, people who are more productive. Or if you have like 10 things doing in parallel and you have to come back like every once in a day, that's not very good. So by reducing turnaround time, it managed to make people more productive. And having a server is also helpful in terms of bringing transparency to the project. This is a sort of a bigger issue in a bigger team environment, where you split the project into smaller pieces, and then often what happens is you have to ask someone working in the project to learn anything, like how to run a test, or where to check out the source code, or which branch they are working on. So when you don't have those information, or when you have to ask someone else to get those information, it makes you hard to participate in someone else's project. Which brings me to the last point, which is to remove the people from the loop. When you're sort of tying some people to some projects, and when it's not easy for them to move on to different part of the project, it creates problems. So the classic example might be like someone goes on to a vacation, or someone goes on to a conference and give a talk about Hudson like me, and then people back in the office, they need to do something, let's say, tag the workspace or post a new release, or things like that. And they can't do it because they don't know which branch to check out and so on, which is silly. And having a server, again, where you could see all those information available, and then it helps you eliminate the people from the loop, and then that allows people to smoothly move between components, which is helpful. So all in all, by doing these things, Hudson tries to save people's time by using more machine time, because CPU times are constantly getting cheaper, but the people's time continues to be expensive. So it makes sense to use a lot more computers to throw at the program, and then to get you concentrated on things that really matters, like design and actually writing the code. And by pushing the jobs to the servers, it managed to keep your workstation available. So often what happens is people run their tests on their own laptop, and while the tests are running, the laptops are not responsive enough, so they can't really do any useful work. So by pushing those work to the server, you can keep your workstation or laptops available for, let's say, interactive use, like your IDE or editors. And so that also helps your productivity. So with that, I wanted to show you a quick demo of how these things work. So I have a terminal that then I could launch Hudson like this, the Java-jar Hudson war. For those of you who are not very familiar with Java, this is how you typically run the Java application, but it's kind of unusual for a web app to launch like this way. So it's this. So it's now running. So this is the main screen, and you can see a few projects. This is my debug installation, so you see some random project in there. So the blue means things are doing great. The red, if there is any red here, that means something went wrong. The build failed, for example. So this build failed, for example. On the left-hand side, you can see like the number of computers that are connected to this Hudson installation. The build and tests are often CPU and I/O intensive, so when you start to run a lot of tests on the system, you often need multiple computers, like the cluster of the build machines hooked up with Hudson to do a meaningful work. And so this is the project I created for this demo. If I go to the configuration, this is the kind of thing you need to tell Hudson to do the work. So you need to tell Hudson where to check out the source code. And once it's checked out, I'm telling it to invoke. So this is an Ant-based project. So I'm telling it to invoke Ant is this target. You can do other things like just executing shell and so on. But in this configuration is useful. This tool-specific configuration is useful to reduce the amount of typing that you have to do. And they also provide data error checking. So at the end of the build, I'm telling it to archive JUnit test reports. So one of the things I pay attention is to do a lot of form validation, because people make mistakes, and when they make mistakes, they want to get back on track very quickly. So let's say if I make a typo like this, it might be hard to see down below, but it actually the server tries to guess what you meant by it. So it didn't find test project X, but it did find this match, so that maybe that's what I meant, and so on. So those are useful to sort of get quickly back on the track. And every time I see my colleagues use Hudson, I learn a new way to improve the form validation. So once I configure the project, then I could I could schedule a build. And because nothing else is building right now, I could sort of start building it right away. And well, this one is like a test project, so it already finished building. So it first checked out the project, and then it ran the build, and it recorded the test results. And so I can now see the test result. I only had 2 tests, so that is not very interesting. It runs too quickly. It's showing 0 seconds. So this is actually a bit interesting that you can see the total number of tests. So there are 2 tests, and then there are 0 failures. But the test number, for example, if you add a new test, you'll see like the +1 here. If you see new regressions, you see like the +1 here. They are showing like the failure count is up. And since I run multiple tests, I can now see the graph of the test results. So in a more interesting project, you see like the test failure goes up and down and so on. You can see other things like, well, you can look at the files in the workspace, and maybe look at all the source files. And then I could go to the directory and so on. Looking at the files like this is often useful, again, when you're talking to other people, and so on. So that's the kind of thing. And since the time is short, I have to cut the demo here, and then back to these slides. So that's sort of some of the basics of the Hudson to get you some feeling of how it does it. So the idea is you could create multiple projects in the Hudson, and then you can have it individually configured and run it. And on top of those basic things, what the Hudson provides, for example, is the permalinks to download the latest artifacts. So this is often useful because not every automated systems, like a test run or your QA cycles, are hooked up to Hudson, obviously. So it's very important to be able to talk to Hudson from the other systems. And one way to make that convenient is to have a URL that always resolves to the latest, let's say, the bundle, so that maybe your test cycle might be hooked with the cron, and you can pick that up by doing wget on that permalink URL. It has RSS feeds to look at the build results if coming back to HTML user interface is not your way. It could also do email and the instant messenger notification with various protocols that people developed, like IRC, Java, and so on. And then the other thing that came in relatively recently is this ability to create like a configuration matrix. So this is particularly useful on testing, where you'd have to say, well, I need to test this software on 3 different OSes with 2 different databases and so on. Like in my day job, one of the things I work on is JAX WSRI, which is the web service toolkit for Java. And that needs to be tested in 3 different OSes that we support, and then 2 different JDK versions because they behave differently. So the way it works is you tell the Hudson that this is the source location, this is the shell script to execute the test and so on, but run this on all these configurations, and it creates all the metrics and run the results. So in this report on the right, what it's showing is it passed, all the tests passed everywhere except in this particular configuration. So there might be something interesting in here that's causing it. So you can see those things with that, like having a large number of things to look at because it aggregates the results. The other thing that I spend a lot of effort in is the dependency tracking because, well, again, in a larger environment, in larger team environment, a big project is often decomposed into smaller pieces, and then the lower level components sort of feed into the higher level components. So what happens is when the bug crept into the library, lower level library, they only get discovered much late in the process. So when that happens, it's often important to know which build of this library was used to produce this bug. Because in that way, maybe some other related change has happened in the library since then, which might have fixed the problem, and so on. So accurately knowing which build which contained all these changes were used for this testing is very useful. So Hudson does that by keeping track of MD5 checksum of the files as they come in and out of the Hudson systems. So by doing that, it could always tell you, for example, the test runs 35, tested the build of the 192 and so on. So that helps to sort of simplify the bug tracking process. There are lots of plugins for integrating Hudson with other tools. The Find Bugs is a tool that's common in the Java world for integrating, for doing static code analysis. So there's a plugin for that. A similar plugin is available for the copy-paste detector in the PMD and so on. Because it talks to the source code management systems, it knows who is making changes at what time and what changes are in it. So you can see that in this project that I took from my work, the Paul Sanders has been like single-handedly making most of the changes, and occasionally you see like more Cadley kicking in and so on. So that's often useful to see when was the last change and what has been changing to sort of get an idea of what's going on. And as I showed you earlier, you can see the files in the workspace and download the files individually, or you could also look at the checksum of the files. The managers always like to see the charts. So even though, well, personally, I'm not sure how useful that is, it can do things like tracking how much time it's taking to build a project. So there are some random bits that I don't know what's going on in those places, but generally speaking, you can see that the project is building between 2 to 3 minutes, depending on where it runs. So the Alfred that down here means the machine, the build machine that this build took place. So that's all. There are boatload of features like that. Another thing that I did was the open search integration. So if you come to the Hudson website, the browser will tell you that you could register Hudson as a search engine. And so what happens is you could then register you could then type in your project name or like the build number and come to the page directly. Or the other feature we got is this build promotion support. This is another plugin. And what it can do is, well, when you have a continuous integration system that's producing lots of builds, it often overwhelms the downstream, especially if they are not automated. So it's often convenient to be able to say, just pick up, let's say, about 1 in 5 builds that are good. Some builds that are actually good and test it, as opposed to some random latest build which might contain some regressions. So the notion of promotion is the idea that once you do certain things, often testing, and qualify that this build is good, then you put some little marking, like in this case a star, and put some star and indicate that this build passed all these tests, so it must be good. So the Hudson could do these things automatically for you. So in this screenshot, what happened is, well, I have like 4 different test jobs that are hooked up to this build. So every time a project builds, these 4 test cycles gets triggered, and if they all pass, this build is promoted. And so this build was promoted 45 minutes after the build has happened. So this is good to know how long you're taking to qualify your build, because it helps to reduce the turnaround cycles there. And then the promotion has happened in 12 days before. So once we promote a build, you can also tell Hudson to do other things, like send out, run some shell script to like copy files or whatever. And then a lot more, like the supporting a distributed builds, so that again, so that you could offload your work to lots of machines in the cluster. In my production system, I have something like 2,000 slaves hooked up to my Hudson system. So that's often how many you need, especially when you start to run a lot of tests. Source code management support is perhaps the area where the community support has been most helpful. And I think the current list of support includes things like the subversion material or the clear case proposed. There's some work going on with Git and Acureb and so on. And tool integration, as I mentioned, with the Findback or the code coverage tools like Emma and Covertura. And then we have some IDE plugins with these 3 major IDEs. And Hudson, despite the fact that it started with the Java in mind, it went beyond Java because people find use for it beyond Java. And so, for example, for Ruby, some people wrote this bridge or the connector, I suppose, which parses the test results. And then another person will also write this plugin which lets you run the Ruby script as the build. So if you're using those, you could do that. The Python has a similar support in that space. The .NET support is really more advanced because there are more people working on it, and it has support for those tools that I personally don't use, so I can't comment on too much about that, but totally useful if you're doing .NET development. But beyond that, because it can use, at the sort of lowest level, you can use Hudson as a way of like the glorified clone that can invoke any shell script. So in that way, you could integrate with any language. So I didn't want to make this talk like a sales talk of Hudson, so I wanted to spend a bit of time about like a highlight implemented Hudson, because there are some interesting design choices that I realized that are not very popular. So one of the things is, well, it produces a lot of data, but so where does it persist those data? And actually don't use relational database for this, because it turns out that one of the issues there is it complicates the installation significantly when you try to support multiple databases. And I don't want to install like all major databases on my laptop to sort of debug all the issues that people are having with different databases. And because Hudson is essentially it's the only thing that's producing data. And so there's not too much issue about the transaction and so on that the database would help. And when the plugins come and go and they evolve independently from the core, it's kind of hard to manage the extensibility, the schema evolution of the database. So, and instead I chose to persist everything in XML, and much like the way the Java serialization works. So the benefit of that is I managed to eliminate essentially almost all the glue code. So it's sort of like, it works like taking a snapshot of object and putting that in XML, which is handy. But because it's so transparent, it sort of got easier for people, especially the plugin developers, to shoot yourself in the foot, because you sometimes don't realize the implication of making a slight changes which sort of affects the persistence structure. So there are both sides, but I was, generally speaking, I'm happy with that. And the other thing I do is the modeling of this. So it's common to model the server in a stateless fashion because, well, when you need to scale, that's how you get the, like, the horizontal scalability. But the Hudson does it a bit differently. It actually has the sort of in-memory object model, the natural representation of how the build server like Hudson behaves in memory as a tree of class hierarchy. So, for example, maybe at the top level, we have this Hudson object that roughly corresponds to the top of the page, which is essentially a collection of projects, right? And then each project has its configuration in it, and they have a list of builds in it, and so on. So, modulo couple of lazy loading here and there, essentially everything in the memory all the time. But it turns out that there are like plenty of memory in the modern computers, and so even if you accumulate like the tens of thousands of builds in your Hudson, this turns out not to be a real problem. So the point of doing this is so that once we have a tree, I could actually map that directly to the URL hierarchy. So there's an underlying library that I wrote called Stapler. It sort of takes these tree of objects and then map that automatically to URL. So this helps to create a rather RESTful URL where you don't see like a lone query parameter that's indicating what the thing is. And it also internally it helps to route the HTTP request to the right object where the data is. So let's say in an application like PHP or Perl, the way people tend to write their application is, well, whenever a page is requested, you look at all the query parameters and figure out which part of the data you're working on, and then you make some changes, and then you render the result. Which is a bit unfortunate way of doing it, I thought. So in this way, because every object, well, the incoming HTTP request gets invoked as an instance method on a particular object. So I could always have all the data available to me within the reach of a single object. So this evaluation happens kind of like a pass expression language. And so when someone reports a URL like Hudson, Joe, Jack Speed, build 11 test report, then what happens is it tries to look at by using reflection, it looks at the method and fields of the object. So, for example, here it recognizes that the Hudson object has a get job method that takes a string. So it tries to attempt these matches there, and it returns another object, right? So now it continues to evaluate the rest of the portion with this object. So now I find the get build, which takes an integer. So yeah, so that sounds like a match, so I take that. And then finally, there's a get test report method that takes me to there. So in this way, just by having a reasonable object model in memory, I could sort of automatically generate the URL binding, which is natural for people. So when you see URLs like this, it's sort of quite intuitive what it means. So it helps people when they are passing around those references to other people or trying to guess, well, yeah, so if you see this URL, it's obvious. If you wanted to see the test report for build 12, you kind of know what you need to do, as opposed to having a long query URL. So that's been very helpful. And then requests are eventually served by either like the views, which essentially renders HTML, and Hudson is using another Apache library called Jelly. And I don't know how many of us know Jelly, but nowadays it's not a very popular choice. But for historical reasons, it do that. It could also use any other template language, but Hudson has already accumulated too many views already, so it's not practical to switch for us. But if anyway, you're thinking about using Stapler for other things, you can use other things like the velocity as a template language. That's fine. Or you can either render HTML, or you can do the servlet-like operations by defining a method called do something. And then that also binds to URL. So this is useful for making some actions before rendering views. But the difference between the servlet and this is that it's invoked on the right instance. So all the data that you have to work on is already available in your object, as opposed to you grabbing things from elsewhere. So the same applies to view. View often has to take a lot of data from the model object. So just having them work like an instance method where you can grab all the data from this object is very useful. Distributed computing is another area that relatively early on I realized that for the build server to scale, you have to use a lot of machines. So I needed a way to make this work nicely. And I realized that the people are lazy, at least I am. So I didn't want to come up with a scheme where I ask people to deploy all the jars of the project in all the build machines in a consistent fashion, because keeping them in sync would be very hard. And even worse, when people forget to keep them in sync, they tend to get the weird errors, like the strange class compatibility related issues and so on. So instead, I opted for the scheme that works like RMI, where sort of the slaves download all the classes on demand. So the slaves don't have to have anything. They just get everything from the master, including the program to execute. So, so the way it works is on the master side, the execution writes like a closure. In Java, it's not very pretty to write a closure, so the syntax is a little more bulky. But the idea here, the example here, is that on the slave, you want to execute this closure that prints out the hello, and then come back to the master and print out another thing. So when you execute this, what happens is the whole closure is serialized and sent to the slave. So the slave has a very thin sort of computing server-like infrastructure that's capable of executing anything that the server sends to you. So once it's transferred, it realizes that the class files that are necessary to deserialize these closures are not available on the slave. So it makes an on-demand call to the master asking, I need these class files, so send them to me, and which sends back. And then once that happens, now it's capable of deserializing the closure. So finally, it executes this closure on the slave side, and then the same thing happens on the way back. It sort of sends back the correct results, serialize that, and then send it back to the master, and then the execution resumes on the master side. So for people writing plugins, which is the majority of Hudson developers, this sort of makes it convenient to sort of come up with a convenient way of doing the distribution. So this is not like where the RPC style explicit remoting, where you have to identify functions up front that are remotable, and then you have to deploy it elsewhere. And then, or there are other schools of thoughts, if I may, for doing those remoting, where you do define like those contracts explicitly so that you could version the server and the client independently. But this is very different from those ideas. And where in this scheme, the remoting unit is rather anonymous. You could create any closure and send it to the slave. And all the parameters are passed rather implicitly. The environment of the closure gets automatically captured. So, and then code gets delivered during runtime, so no upfront deployment necessary. So the part of the reason I opted for this is for the extensibility, I guess. That is, well, I'm sorry. So the point of doing all these work by my own, besides it's fun to do so, is for enabling extensibilities. So, so the stapler allows plugins to seamlessly integrate into the URL hierarchy of Hudson, which is much harder if you have a static sort of JSP-like model. And this deployment-free distribution is also convenient for plugins because now people don't have to manage so many different things. And the lack of database helps people, the using XML helps people come up with different ways of storing data without messing with the database schema, which is often painful, and so on. So most of these objects that I showed you earlier, like the jobs and SCMs and how to build a project and what's the trigger and so on, they're quite extensible and pluggable. So that's how people hooked into the Hudson, and then they started writing their own SCM support or start writing their own instant messenger support. And all the built-in features like CVS and subversion and all that, they use the same mechanism. So in that way, I make sure that the extension points are sort of used, are properly designed in a usable form. And so that's a little insight into how I do Hudson. And then the other thing is that the last part of the talk is about what kind of things I emphasize in Hudson, which I thought might be interesting to some folks. So again, one of the things I really tried to promote is to simplify installations, because one way to put that is people are lazy. Well, another way to put that is people just don't have enough time to waste on crappy software. So Like if it doesn't work in the first hour, maybe they just might move on and never come back again. So it's very important that the first expression of things are easy and nice. And so in Hudson, I try really hard to simplify the installation. So, one of the end result is to be able to just download this WAR file, which is already a compressed form of the archive, and then you can just run it right away. And this is actually very uncommon for any other server application, which at least require you to unzip the application and then maybe install a separate application container and maybe configure the database, and then you can finally get going, which is a lot of work. And that's also a lot of steps where you can shoot yourself in the foot and make a mistake. So this quite drastically simplifies that. But actually, then it turns out that I can even simplify this. That is, I don't even have to ask you to download anything anymore, thanks to the technology called Java Web Store. So actually nowadays, all you need to do to try Hudson is to come to our website and then just click a Java Web Start link. And then what happens is if your browser is properly configured with Java, which it's supposed to be, and then it starts downloading this Hudson right there, and then it executes things. And then all your data is stored locally. So even if you shut this down and come back to this later, you still have all the data left intact. So you really don't get, the installation really never gets any easier than this, especially for server app. Or the other thing is the simplifying configuration. People make silly mistakes like the typos and not knowing the right CBS root string. And I don't want people to become diligently searching emails for the correct CBS root string or the right directory. So one thing I put a lot of effort in Hudson is to help people, help Hudson correct people's mistakes sort of automatically. And so as I showed you earlier in the demo, there is extensive on-the-fly form field validation. It's not just about telling you that there's an error, but it actually also tries to guess what the problem was and try to suggest to you what was the changes. So, for example, if you make a typo in the project name, it tries to look for the nearest match and try to tell you that maybe you meant that, and so on. Or there are typical deployment errors in Hudson that you deploy to the servlet container that doesn't support the version necessary for Hudson. So it has an explicit check for those things, and it gives you a nice graceful error messages as opposed to the blow up and just choke. So those are helpful in sort of helping smooth out the experience of people with Hudson. But this is one area that still needs a lot of room, still needs a lot of improvements. Every time I see my junior engineers using something like Hudson, I get to see how they are making mistakes, and that feeds into my cycle. So one of the things I'd like to ask you is, when you make some mistake, don't blame yourself, but blame your tools for not reporting the errors, and tell us what we could do better. Another thing is to reduce the barrier of entry to the project. So I've been doing various free and open source software development of different sizes, and I realized that the typical project runs in a very sort of stringent fashion. For example, they emphasize on meritocracy, meaning for you to become a committer, you have to prove yourself substantially for a substantial amount of time. Right? Before you get to have any say on any sort of development, then you have to prove yourself for a year or more. And that's good for big projects where you have to sort of chase away the potential contributors and sort of filter them. But for most of the projects that are small, Hudson is no longer exactly a small project, but for many of the projects, the trade-off is wrong, in my opinion. So in Hudson, I'm trying something else. So instead of sort of asking people to prove themselves before letting them commit access, I almost give away commit access right away, like if anyone asks it, or even if anyone submits just a single patch. But what happens is that instead of that, I try to sort of split the code into plugins, so that's where the architecture helps, and then sort of emphasize the ownership of the plugin to individual people. So that creates this sort of that sort of works very nicely with people's sort of independent mentality that they get to own their part of the code and they can do anything with it and they don't have to talk to me about making any decisions there. But I still sort of have this, because they feel this entitlement to their parts, they respect the other people's entitlement to the other part of the code. So they don't, most of the regional people still talk to those people before making any changes to the other parts of the code. So I still get the same effect of, avoiding random people committing randomly, but without having the formalism of long committer access. And then another benefit is when some people move on, which do happen, and then the ownership is gone. But because the people have a commit access, they already is technically capable of making changes to those ports. So it makes it rather easier for having other people fill in the role of the people who left. So it's a different trade-off of running an open source project. But I find this working rather nicely for small projects where the main issue is soliciting more contributions and not about sort of screening people away. So it's something that I thought I should mention. The other thing is, since I emphasize on people developing plugins, I spend a lot of effort creating an environment for plugin development. So that is sort of emphasized in terms of the Maven plugin, and it does everything from initial skeleton plugin generation, so that you can start with some simple, the skeleton build script and all that, to handle all the complicated compile time processing that this framework requires. It also comes with a debug support. So just with a single command, you can launch Hudson with your plugin and then have set up the dynamic reloading of things so that you can see your changes as you make them without reloading or restarting the applications. There's also release support, so when it gets time to release your plugin, it posts the announcements automatically, it uploads the plugin to the central repository and so on. There's a documentation available on the website thanks to the help of the community. And so those efforts actually sort of become fruitful. So today I think I have something like 40 plugins available of different quality, but they are good. So I guess the takeaway is if you want to have something happen, if you want to see something happen, you need to make it easy enough so that people could do it. Just having stuff doable is not good enough, and it just needs to be, it really needs to be easy. So that's one of the lessons that I learned. Another bit of experiment that I'm doing with Hudson is these frequent release cycles. It partly started with my frustration of my day job where you get to release only every once in 6 months maybe. And so in Hudson, the current release model is every time I make maybe 4 to 6 RFEs or bug fixes, I post a new release. So that typically amounts to every once a day or every once a week on average. So that adds up all in all to 185 releases for the past 3 years. And in a way it's a bit crazy, but if I start thinking about the fact that, well, the tests are all passing, and I'm using it by myself, so it seems to be working, then if I make those fixes that the people want it, the people want bug fixes, obviously, because it's causing issue for them. So then I started thinking, why shouldn't I just ship them so that they could pick up those bug fixes? And then it creates a great turnaround time for bug fixes, especially in the new features. And people apparently love this. So, for example, when you report a bug and get a fix in, let's say, 3 days, it really sort of gives you an incentive to report more issues. And that's one of the things that's working greatly for Hudson. So nowadays I get more issues, more RFEs and bug reports than I can handle, so it's becoming an issue. Although the obvious downside of this is that people are not going to be upgrading every release, obviously. So when there are so many releases, people lose the track of which version they should upgrade to. So one of the things maybe I should have done is, instead of trying to use this 1.x scheme, so today the version is 1.185, I could have used the 2 scheme where you signify the amount of changes by using the second and third digit. So that might be something else that I might do later. So in wrapping this up, so I encourage you to try Hudson out if you haven't done so already. It's very easy to get started and install and configure, and thanks to all the web UI and the form validation. It's primarily developed for Java, but it's also great for non-Java developments too. So one of the things that I'm feeling is we tend to create this small silo for different languages in the open source community, but it doesn't have to be that way, I think. So I wanted Hudson to be sort of more language neutral in some way. So I hope even if you're not using Java, you might still, I'd still encourage you to try Hudson. And then, the help is always appreciated. There's lots of ideas about what you can do with Hudson, but there are not enough people. And conveniently, Sun is currently running this award program where I think within the 6 months from now or so, their contribution could actually win real money. Like, I think it's up to tens of thousands of dollars, actually. Unfortunately, I'm not eligible, but I'm sure you are. So there's a great chance of winning some real award if you contribute something or like write docs or anything. And then there's finally the website and the email address if you need to talk to me. And with that, I guess I'm done. So I guess I'll take any questions. Most wanted feature. Personally, that's going to be a better Maven support because in my day job, more and more projects are moving to Maven, and I needed more of it. But yes. So that's it, I guess.
Is there some way of auto-updating if you're releasing every 1 to 7 days, or do you just have to keep scanning the website if there's a new release?
I'm sorry, say that again? I didn't get the question.
So is there a way of doing an auto-update, having Hudson check if a new version is out with bug fixes? Or
yes, it's one of the things I wanted to implement. There's like a whole new idea. Well, if your Hudson installation is connected to the server, and you get the update notifications for all the Hudson or the plugins, or just with the button mouse click, it updates itself automatically, for example. That would be very handy. And I can do other things like asking you to help me with the statistics. And I'm always curious about which part of Hudson is used more and less, because that helps me like prioritize my work. So there's a whole bunch of things I could do if I connect people's Hudson with the server. But that's one of those many ideas that I have, which I don't have time. So if anyone is interested in contributing, that's actually a great area.
Could you give me 3 reasons why I should use Hudson instead of, say, cruise control?
So your question is, why should you use something like this instead of cruise control?
The question is, there's loads of tools doing automation builds out there. Currently, I'm using cruise control. Why should I switch to Hudson? What would I get from the switch?
Okay, so one of the benefits is, it's much easier to configure because everything is on the web UI, and any mistake you make is going to be corrected right there as opposed to using cruise control. The other thing is it's a single server that can host a large number of projects. So in my day job, I have something like 400 jobs that the different people hooked up to a single system. But only I need to babysit the whole Hudson installation, whereas in cruise control, if I understand correctly, you have to have one server for one project, and each project is on its own to set things up. And in Hudson, being aware of many projects, it also allocates resource wisely. So if this node is already building something, then it tries to move another build to someone else, and so on. So there's a lot of things you can do if the server is aware of multiple projects at the same time. The dependency tracking is another one of those examples. So I guess that's another reason. I think yet maybe the third reason is with Hudson, the web UI is a central part of it. And then in any team environment, I think having a server where you can come and see those things is essential. Whereas in cruise control, it's more meant to be demoed, and I feel that the UI is an afterthought. So, right. So those are, I guess, the major reason. But the cruise control is a good software. I mean, it's being used by many people. I don't want to discredit the people working on it, but If you ask me why you should switch, I guess those are the main reasons.
Hello. I certainly appreciate very much your philosophy of trying to destroy these walls between the different communities centered on different programming languages. But I have one concern with this approach to distributed computing. Suppose I have as a task to do some C compilation in my build farm. How will I go about packaging a C compilation task and sending it over? So it's all nice to have this approach where you don't have to configure up front the build machines in the farm. But the question is, how can you pack and send over a C compilation task?
How do you say, if I understand you correctly, your question, so your question is, how do you have like tools necessary to perform your building all the slaves?
Yes.
So yeah, so it doesn't sort of, this is not like a cluster maintenance software. So there's definitely a part of it which, a part of the maintaining a Hudson cluster is definitely about maintaining a cluster. So you have to keep them up and running. You have to keep those clocks in sync. You have to have the right set of tools available and so on. So those work still needs to be done, and there's not much I can do in Hudson to automate those. So for example, in my day job, I have a small shell script, a Perl script actually, to deliver all the tools like the JDKs and ANT and C compilers to all the slaves in the right architecture, because I have slaves with different architectures. So those are done outside Hudson. So if that's a question, then unfortunately it's still up to you to do those things.
Okay, thank you. I have another question. I would like to understand, supposing that I have some policy, like I want to make, I don't know, warning 274 fatal. I want this warning to turn some task to red in my reports. Where do I configure that exactly?
Policy. So you have policy about where to run? Is that what I mean?
No, I have a policy that says some warnings are fatal. I want to chase them out from the code. Where do I configure that? Where do I put the code that post-process and detects this warning and then turns the result to a failure?
Okay, so some of the plugins do that. For example, the violations plugin help you set up those like arbitrary criteria. You could say like, well, if you have more than 500 find bug issues, consider the build to be failed because that's just too many and so on. So the short answer is it depends on plugins. So it's not like, well, yeah, I guess the nature of it is sort of essentially tools and domain dependent. So that's how it works.
Okay, we've got time for one more question if anyone has one. Okay.
One of the things, I mean, it's lovely, as you said, to be able to run multiple projects off one build machine, but one of the things we've discovered is that you have to be fairly disciplined about resource usage. Say if you have a port that your tests use, you have to make sure that none of your projects conflict, because if you happen to be running two builds, or you might have a port open. So is there any, Hudson, as of now, and it's unreasonable to expect it to do automatic dependency checking at that level?
Yeah, in fact, there are some supports. For example, the TCP port example you mentioned is quite handy because we had the same issue. You know, some of the web app test requires port 8080, or some SMTP, some Java mail testing requires port 25. So there's a plugin in Hudson that sort of allocates those things. You could declare that this job requires these port numbers, so don't run this with other things that require the same port number. The other thing Hudson could do is you can tell Hudson to give me some like 5 free TCP ports, and then Hudson makes sure that it doesn't allocate the same port to different jobs running on the same time. So that's another way to do that. And then there's another plugin for like controlling the other exclusiveness. So, it's called Latches and Locks plugin that Stefan Connolly did. And I haven't used it myself, but as I understand it, it also does something similar. So if if two things need to use the same database, make sure that they don't, get collide with each other and so on. So there are various ways to do it. Yeah.
Okay, that wraps it up. Thank you very much.
Thank you very much.